Hello, everyone. Welcome to the second week of our class. In this week, we'll continue to discuss the remaining slides in Module 1. Last week, we talked about a brief history of data visualization. We mentioned a few famous people in the history of data visualization. We also talked about some examples of optical illusions. So let's look at the remaining slides. So in summary, we live in a world that is rich with data, which helps us look at the past, present, and the future scenarios. With data, we can understand our world and make better choices, change people's behavior, grow wealth, and improve quality of life. Data visualization allows us to do these things by asking questions through data. To understand and interpret data, we need to engage in specific activities of human cognition, such as asking questions, discovering patterns, drawing meanings from the data. It's a creative, visual-driven process that requires empirical and mathematical skills. It also requires subject matter knowledge in the field. Some of the rules will affect the way we process information. So with the help of software tools, we can normally find it easier to review the answers, but sometimes computers cannot figure out the meanings about data and how it connects to the business or problem and what to do. In addition, the data needs are always changing. So that's why it takes a lot of training to interpret the data, to interpret the intelligence behind data. So we need to combine data with tools in our human brains in order to develop business intelligence. So look at this example. Do you think it's a data visualization or not? Yes, this is indeed a data visualization. It's actually a dashboard featured in Stephen Field's book, Information Dashboard Design. So we will talk about dashboard later on in this semester. So how about this? Do you think it's a data visualization or not? It's the website of the Cleveland Museum of Art. And you see a lot of pictures on their front page. And when you click each image, when you zoom on each image, you can actually see the actual, the description of this image. And you can also bring up the details of the individual pieces about the data, the medium, and the dimension of the artwork. And we can also drill down into all the details. So this is certainly also another way to present data, present information. It can also be considered as a special type of data visualization. So in conclusion, we are trying to understand our world and make better choices to change behavior, enhance wealth, and improve quality of life. So it's important to learn about the way our brains work, how we perceive and process data, how to improve people's interpretation or perception of data, which is essential to achieving these goals. So now let's talk a little bit about the building blocks of data visualization. Specifically, we'll focus on the pre-attentive attributes. So we are born with an enhanced visual path to cognition. About 70% of our sense receptors are in our eyes. 40% of the cerebral cortex is involved in processing visual information. So visual perception is intimately connected to understanding and visual connection to the brain has more bandwidth than other paths. So that's why it's important to learn by watch people doing something, so which is also reflected in language, like we normally see, I see what you're talking about. Seeing is believing, sketch about, idea, etc. So our brain is powerful, but our working memory is limited. So long-term memory is very important. At the same time, working memory is limited to a small number of chunks. So we can only memorize something for a short amount of time because we have limited working memory. So visualization allows us to consolidate complicated statistics so we can process more data simultaneously. That's why data visualization is a powerful tool to help people to quickly grasp the complicated concepts or complex statistics in a very short amount of time. However, the picture in data visualization is not the end goal. It's what we want to tell. It's the story we want to tell behind the picture, which is more important. So how do we make sense of visual world with our brains? So we normally tend to make sense of the image being presented based on the following visual variables. We call these pre-attentive attributes, like shape, texture, orientation, value, color, size. And the two horizontal vertical dimensions, which are encoded in position and order. So in addition to those typical visual variables, there are also some contemporary variables based on the emerging digital technologies, such as motion, medium, and context. So we are increasingly trying to incorporate motion or animated features in our data visualization. So that's important. Another important factor, or maybe attribute. So medium is also another important factor. We can nowadays develop data visualization on any types of medium, like as small as the smartwatch, as large as a larger screen. So the third one is a context. Context indicates the sensory and emotional environment, which is also very important in the contemporary environment of data visualization. So first, shape is a very important pre-attentive attribute. So notice in this example, we may see the scintillating effect we mentioned last time, because we have too many dots piled together. You may see the gray dot in between all these grids. So it's easy to see the different shapes among all these circles. It's easy to see the triangle on this triangle. So this could be useful for categorical comparison, but it may not be useful for a quantitative comparison. Next is orientation. It's another very important attribute. So if you change the orientation, it's very easy to detect the difference. So here the arrow pointing up can mean something has increased, or it can mean something different in a different context. Color is a very powerful pre-attentive attribute. So color blue versus red is very commonly used comparison. So we'll talk about color in a separate module later on. Color is more than just color hue. It can be color in different dimensions. It can be color changing to the saturation, which is intensity. It can be colors changing to the value, which is just brightness. So this is called the color wheel. It's based on RYB a subtractive color model, which based on the 3 primary colors, red, yellow, and blue. It's a little bit variation of the original color wheel. So you can see we have the colors across from each other as complementary colors, and colors next to each other being analogous colors. So this is another color wheel based on RGB 3 primary colors, red, blue, green. It's the common color model used by computer displays. So all the other colors are essentially derived from these 3 primary colors, RGB. It's called RGB system or RGB color wheel. So color can be used in data visualization in the various ways. So here are the 5 primary ways that we can use color in data visualization. Sequential, divergent, categorical, highlight, alert to serve different purposes. So we'll come back to talk about these different methods later on. So look at this example. Do you think the use of color actually enhance or distract the attention of the audience? So let's take a closer look at this figure. Do you think it's the best way to encode color in the data or not? So I'm sure you get the answer. So color, in terms of color, the value can be changed to encode quantitative value. For example, in this figure, so it can be changed to reflect the difference of individual unit from all the other units. So color can change its values in terms of its intensity. So texture is also a very important pre-attentive attribute. It was commonly used to describe like the differences when we want to display black and white figures. So in some scholarly articles, when authors choose to print their articles in black and white, they have to use the texture, maybe patterns, to indicate the differences in their figures. Size can also be used to encode both categorical or quantitative data. So sometimes size may not be good for making precise quantitative comparisons, as we cannot precisely tell the differences, or maybe how large the big circle in comparison to all the other circles. So it may not be very accurate. Position is also an important attribute, pre-attentive attribute. So position can be in the much better way to show precise quantitative comparison than actually the previous attribute size. So it's easier to measure the distance in the position variable. So order is sometimes also very important pre-attentive attribute. So in this chart, you can see all the bars are ordered in alphabetical order. So it's not easy to answer some of the questions like what is the top provider, what is the bottom provider, what are the top 3 providers, etc. So if we sort this bar chart, so now we can easily answer those questions. So this tells us that order can sometimes be a very useful pre-attentive attribute to help us to quickly get the information to the audience. So here is a short video. Let's take a look at the summary of those pretentive attributes.
They say knowledge is power, but how do we make knowledge powerful? Especially when that knowledge comes in the form of data. Lots of data. How do we find the meaning?
Sorry about the pause. Let me replay it.
They say knowledge is power, but how do we make knowledge powerful? Especially when that knowledge comes in the form of data. Lots of data. How do we find the meaning? Tell the story. Share the story. Infographics, where data meets design. What makes good data visualization? Take a few seconds to count the sevens in this number set. How many were there? Not sure? Now try. A simple color change makes comprehension almost instant. Color is one of several pre-attentive attributes, like size, orientation, flicker. Visual clues that the human brain processes within 250 milliseconds. Now imagine that we're not looking for specific numbers, but patterns. We can use color to show correlation, size to show quantity, or orientation to show trends. And not just data. The power of design can be used to better communicate all sorts of information. Processes, hierarchy, anatomy, chronology. Better communication through innovation. Because your message is only as good as your ability to share it.
Okay, so what did you get from this video? It's a good summary of all the pretentive attributes we just discussed. So it tells us that data visualization is powerful. With all these pretentive attributes, we can interpret data and deliver the message to the audience in a very effective way. So in addition, motion, medium, and the context are also important influencers on how we perceive data and information. So we have two, as human beings, we actually have some built-in biases. So psychologists, they recognize two thinking systems that we normally use to make sense of the world, which we call this system 1 and system 2. System 1 is a bottom-up system. System 2 is a top-down system. In system 1, we operate automatically and quickly with no or little effort, with no sense of voluntary control. With system 2, we need to actually allocate attention or effort. We want to make effort to make sense of the world, to actually to understand complicated situations surrounding us. So in comparison, system 1 generates impression, intuition, intention, and feeling for us to continue to operate system 2 to solve very complicated problems or questions when system 1 cannot handle those difficult situations. So look at this example. So are you using system 1 or system 2? So the first impression that system 1 tells us that is we have this like twins, one is happy, one is crying. Then we want to understand what has happened. Why the left girl is smiling, but on the right-hand side, the other girl is crying. So that's how we use our two systems trying to interpret the world surrounding us. So here's another example. So what's the answer? What's the answer for this multiplication? So can you tell immediately? So if you are a prodigy, maybe you can immediately tell the answer from your mind, from your mental math. But for normally, we cannot immediately tell the answer because system one will not work in this situation. We have to use our system two. So normally we need to get a piece of paper to write down these two numbers to solve this problem by exerting additional effort. So how about this example? So by looking at this data visualization, can you make sense of it? So apparently it's not easy to understand the purpose of this visualization by only using system one. It takes a lot of effort for us to try to understand the purpose of the author. Apparently it's not a good data visualization. So a good data visualization will require people to use less of system two, so they can immediately use system one to quickly grasp the purpose or the message being delivered from the figure. So impressions in system one affect the conclusions of system two. So these two systems work together. In other words, presentation impacts the way data is perceived, mood and emotions impact critical thinking. So however, sometimes oversimplification can result in distorted understanding. If you make it like too simplified, maybe so people will just misunderstand what you want to present. If it's too simple, maybe you may actually you may not be able to present the real meaning behind the data. Okay, so that's all I want to present for this module. If you have any questions, please let me know.